Now let's see about pushdown automata. Pushdown automata is used to recognize language generated by the grammar G. This grammar is context-free grammar. So pushdown automata is used to recognize language generated by the context-free grammar. What I mean by saying recognize is it will have a path, all the strings that belongs to the language generated by the grammar will have a path from the initial state to final state in pushdown automata. That is what I mean by saying recognize. I repeat, all the strings which are generated by the grammar will have a path from the initial state to the final state in pushdown automata. Now, pushdown automata is used to overcome the limitations of finite automata with memory in terms of stack. What I mean is, pushdown automata will have two types of data structures. One is input tape, another one is a stack. So we can say pushdown automata is finite automata plus a stack. So let me define pushdown automata. Pushdown automata can be defined with the help of 7 tuples. Q, sigma, we'll use the letter M to define pushdown automata. Q, sigma, Q naught, F, delta. These terms are not new for us. These are the terms used to refer finite automata. And additionally, we have a stack data structure in pushdown automata. So we will have two more terms, gamma and Z naught. So what is Q? Q is set of states. Sigma is set of input symbols, or we call it as alphabets. Q naught, initial state. F, final state or accepting states. Final state. Delta is the transition. Delta is transition, and it is defined as, see here we will be looking into the state, input tape which can hold epsilon values also, and at tape symbols. So looking at the present state, looking at the input tape and the stack contents, we will move to another state with either a push or pop operation in stack. So the tape symbols will be replaced with more number of symbols, or it will be replaced with epsilon. In case of pop, the tape symbols will be removed. This is how we'll be defining delta transition in pushdown automata, that is transition in pushdown automata. So gamma refers to stack symbols and Z naught refers to the bottom of the stack. Z naught refers to bottom of stack. Coming to delta transition, so in pushdown automata, you will be having a tape. It is called as input tape. And you will be having another data structure called as stack. And the bottom of the stack will be usually referred with the help of Z naught. Now, until we place any string on the input tape, it is assumed that all the tape cells will be filled with epsilon, and there will be a pointer indicating the tape, X pointer, and there will be another pointer to the stack which indicates the top of the stack. If nothing is there, bottom of the stack will be referred with Z naught, so Y will be pointing to Z naught. So this X will be capable of moving to the right one step always. So this is what is the data structures that is available in pushdown automata. Now coming to the transition, So in transition, while making a transition, we will look into the current state. We will look into the current state and whatever is there in the input symbol, input tape, that is what is referred with the here, that is what is referred here, sigma union epsilon. And what is the top of the stack? Whatever is the content that is available in the top of the stack. Based upon these three values, we will move to some other state with either push along with some move. We call it as moves. Okay. Along with a push or pop operation. This is how we'll be defining delta transition. Before going into examples of pushdown automata, we will see, we need to know about acceptance of pushdown automata. So what is acceptance of pushdown automata? See, pushdown automata can be accepted by two methods. One is empty stack method, another one is final state method. Final state method. Let me first define empty stack method. First one, a string W is accepted by PDA, that is pushdown automata, with empty stack. Empty stack can be given as W belongs to sigma star, that is this string is formed with a set of alphabets. The initial state is Q0. W will be placed in the input tape and bottom of the stack will be Z0. After one or more transitions, it should arrive at some state, this for some Q belonging to capital Q, some state with, here also the string should be completely traversed. So the string, if we place the string here, if it is completely traversed, the end of this string will be referred with the help of epsilon. So Q comma epsilon comma epsilon. So this is epsilon in input tape and this is epsilon in stack. So what does it mean? We are removing that Z0 also and the stack is completely empty now. That is acceptance of pushdown automata by empty stack method. Second, a string W is accepted by pushdown automata using final state method is given as, here again W belongs to some combinations of input symbol. We will start with the initial state with the string in the input tape and Z0 refers to the bottom of the stack. After one or more transition, we will arrive at QF comma epsilon comma Z0, where QF belongs to final state. QF belongs to final state. And this Z0 refers to the bottom of the stack. Bottom of stack. Okay. Now see the difference between empty stack method. In empty stack method, at the final state, you will have epsilon both in stack as well as in the input tape. And you can be remaining in any state that belongs to capital Q. It can be even final state or non-final state. But here in final state method, your input tape should contain all epsilons, bottom of the stack should be Z0 and you should be in one of the final state. That is acceptance of pushdown automata by final state method. This covers the introduction to pushdown automata. In next video, we will move on to some examples of how to design a pushdown automata for any specific